welcome. This is Aurora with Supercharged Math. We have so many fun things to do today. We are, I know my slides are stuck on the decimals one. Give me just a second. We're going to bring everything up. How was your weekend? Did you guys have a good holiday? The United States folks who celebrated Thanksgiving? Yeah, did you guys have a good break? Awesome. Yeah, me too. You guys ate way too much, right? Me too. Okay. Let me turn on my studio lights. There we go. Can you believe we're more than halfway done with our math unit in decimals? Didn't it like fly by? I'm still kind of wondering what happened to September, October, and most of November. Yeah, me too. Okay, so yes. All right, so we are going to have some fun today. Let me just make sure all the live streams are going. It looks like we are live here. 1, 2, 3, 4. Let me check one more just to make sure. Do you guys have any math jokes for me? Can you give me your best math jokes? Yes. Okay, type it in. Now's your big moment. I am getting together a party because we're going to have a party pretty soon. So, yeah, if you have something you want me to include, type it in. Make sure it's a nice one. Okay. All right. And it looks like all of our streams are working. Excellent. Okay. Hey, guess what? I actually have a couple of things. So if you have a parent nearby that can hear me, just know that the new live schedule or the live class schedule for winter and spring is up. Let me show it to you here. This is the live page where we're broadcasting right now. And then it says for grades 4th through 6th, you can see we've got Unit 1, Unit 2, and then this is January. And we're also going to have a multiplication workshop scheduled. And then how many of you are excited for geometry? Anybody like geometry? Have your parents ever tried to back into a space or pulled their big car into a space and you're like, Mom, it's not going to fit, right? Okay, so that was a geometry thing. Or maybe who's in charge of like saving leftovers after dinner? Yeah, there's usually one person can go, that's not going to fit. And the other person's like, of course it will. And it like spills everywhere. All right. And then we also have some pre-algebra we're going to do this year as well. Okay, so this is up. You get to it by going to grades 4th through 6th live classes. And so you can also print them out. I've got the printouts of the teaching schedule for you too. All right, so that was the big announcement. Let's dive in because I know we got a lot of fun math stuff to get started. Okay, so let me go back to let me save this tab for later. Okay, so let's do our official start. You guys ready? All right, give me a big drum roll. Dun, da, da, da. Here we go. Hello and welcome to Decimals session number 5. Today we are going to look at division. Yay! All right, so if I have 4 cookies and I'm sharing them between you and me, how many do we each get so it's fair? This is not a hard one, right? 4 cookies, we each get 2, right? You get 2, I get 2. Right, good. All right, what if there's 6 cookies? Now what do we do? Yeah? How many do we each get? Can you show me on your fingers? Yeah, you're doing division. Not that hard, right? Okay, if you have the handout for today, you're going to grab it. If you don't, you are just going to grab a pencil in your notebook because that's all you need. Okay, so this is dividend, quotient, divisor. This just tells you what they are. I don't really care if you know what the names are, just as long as you know to get from, if I have 18 cookies and 3 people, everybody gets 6. And you know how to turn this guy, here, let me highlight it here, this guy into this guy. And you know where all the numbers go, okay? The 18 is the numerator, that goes in the box. This is the 18 cookies, and this is the 3 people. How many does everybody get? They get 6, okay? So as long as you can go from the fraction to this thing, that's what I care about the most, okay? So I put it up here so you can use it as a reference. All right, and this one's only a couple of pages long. Just real quick, on the back page, it's graph paper. Do you see that? Sometimes when you're doing division, like you guys remember doing long division from your other math classes, these numbers can get really kind of hard to use. So usually I'll have kids use graph paper, especially if your writing isn't the neatest in the world. So graph paper can help you keep things lined up so you don't make mistakes. So especially as you're first learning, you're welcome to print out as many of pages, this is page 3, as you'd like to do division. If you've got neat writing and you can read it without making mistakes, then that's great. But with things like this, sometimes it can get you can see how it's sometimes a little hard to see which one is in which lane. Yeah, okay, so let's go ahead and get started. Now, if I were to say, all right, I actually baked a lot more this weekend. I made 20 cookies. All right, and we have 4 people. 1, 2, what? Okay, one of them's doing a handstand, sorry. 2, 3, and 4. How many cookies does everybody get? Yeah, this is not a hard one. Show me with your hands. Good, write a math expression that tells me that. What's the math expression? Okay. You could say 20 divided by 4. That would work. You could say 20 over 4. That would work. Sure. Okay. All right, you could do this. All of those work. This isn't really an expression, but these two are. Okay, we can fractions. All right, this all describes the problem of 20 cookies. Here, a plate of cookies. A lot of cookies. Maybe they're chocolate chip, I don't know. All right, 20 cookies and 4 people. How many does everybody get? This is how you'd write the math thing to solve that. Okay, and before we had the 18 divided by 3, we did that one. How about this one? Now you've got 15 soccer balls. Everybody would like some. You've got 5 kids on a team. 1, 2, 3. I don't know what happened to that kid's arm, sorry. 4, 5. You draw stick people fast. Okay, how many soccer ball or gumballs or whatever? How many does everybody get? Can you tell me? Yeah, everybody gets how many? Everybody gets a stack of 3. So we're doing 15 divided by 5. 15 divided by 5, right? All right, smile if you're remembering this from the furthest reaches of your mind. Remember doing division? Yeah, okay. No, you don't remember doing division at all? Oh, we're in trouble. Okay, now this is if it's even, right? These are easy because they are coming out fair and even. Have you ever had the problem like this? And your mom's like, share with your sister, and there are 3 of you, and there are 2 cookies, but 3 people. You ever had this problem? And you're like, somebody's getting crumbs, right? I've seen kids solve this one by saying, all right, I'm going to split 1 in half, and we'll give the 3rd person the whole thing. Is that fair? I get half, you get half, and then the baby sister gets the whole thing. Is that fair? Does everybody get the same? No, the divisions aren't the same. That's a solution, but that's not a fair solution. Okay, so how do we do it when the numbers are not even, when there's some left over? All right, so 2 cookies divided by 3 people. That's how you'd write that, right? 2, everybody gets how much of a cookie? 2/3 of a cookie. Yeah, and to do 2/3 of a cookie, you'd actually need like a pair of scissors or a knife, right? And everybody would get that much. And that would be fair, and you do that 3 times. All right, so let's do numbers without pictures. Okay, if I had, say, 21 gumballs, and I have 4 friends. Nod your head, yes, it goes in evenly, or no, it's kind of messy. Which one? Kind of messy, isn't it? Okay, so how do we do this? Well, you remember from division before, my guess is you might have remainders. We did this in fractions. Okay, let's set this one up. So the number of stuff you're dividing, that goes in the box. Okay, so draw yourself a box around it. And then the number of people, or the number of piles that you're making, that goes there. Okay, so we're just rewriting it. Okay, there is always a decimal point hiding here if we need it. So just remember that, okay? It's hiding there. I'll put a little dot there so you see it. Okay, so how do we do this problem? Well, you take your fingers and you go 4 goes into 2 none times. Okay, so then you move your fingers over. 4 goes into 21. How many times? 4 times something. Can you get close to 21 but without going over? 4 times something goes into 21. Do you remember your times tables? Yeah, that's right. I'm seeing it. Good. 4 times 5. What is 4 times 5? 4 times 5 is 20. What is 4 times 6? That is 24. That's too big, so we don't want to use that one. All right, so we're going to use this one, 4 times 5. So put the 5 up here. So then we say 5 times 4 is 20. And here, I'll do it in a different color so it stands out. Okay. And then we take the difference. Okay. So we've already accounted for 20 of that, but we have a little bit left over. So we have 21 minus 20 is 1. Now remember I said there's a decimal point if you need it? You can add zeros all day long and nobody is going to care. That will not change the value of the number. We talked about that before with place value. So now what we do is we say, okay, we're going to drop just one of the zeros. Let's drop one of those zeros. Okay, and now take a look. We have 4. How many times does 4 go into 10 without going over? Okay, there's 4 times 1. That's 4. It's not quite enough. 4 times 2 is, oh, you can't see that, 8. What's 4 times 3? 12. Oh, that's too much. Okay, so I like this one. So 4 times 2 is 8. Okay, so I've got a 2 here. 2 times 4 is 8. And we'll take the difference. Okay, and the difference, 10 minus 8 is easy to do, right? 2. And then we're going to drop this guy. Okay, we're going to drop that next 0 down. You just keep adding zeros as many as you need them. Okay, how many times does 4 go into 20? We already did that one, didn't we? Okay, so I can put another 5 up here. 5 times 4 is 20, and now I have 0 left over. So there is nothing. Here, let me back up the camera so you can see the whole page. Okay, so there is nothing there. Now, is that the answer? No, because I forgot to do something. Do you see that decimal point? So the decimal point, all you do is you push it up. Okay, this is your final answer. So 21 divided by 4 equals 5 and 25/100ths, or 5.25. All right, I'm going to pause just for a second. Let me know if you've got questions. Okay, you're right. We do remainders. That's with fractions. So for decimals, we use this method. And are you seeing how grid paper would come in handy here? Right? Because the grid paper would keep all the numbers in their same rows, right? And it's super easy to keep track of things. So you're welcome to use grid paper for this part if you like. I'm going to try to draw as nicely and neatly as I can. Okay, shall we continue? All right, if this is easy, then I want you to do the next one and see if you can race me to the answer. All right, I've got 29 marbles and 5 people. All right, nod your head, goes in even. Shake your head, messy. Messy, messy. Okay. Can you tell me, what do I put in the box? What goes in the box? Yep, the 29. Good. Okay. And then what goes here? Yeah, the number of things that I want to go into. Good. All right. So 5, and so you take your hand, you go 5 goes into 2, it doesn't. Because 5 times 1 is 5, that's already bigger than 2. So then you expand out. 5 goes into 29, how many times without spilling over? All right, so 5 times 4 is 20. 5 times 5 is 25. 5 times, that's close, is 30. Oops, too much, right? So which one of these do you like? You like that one? 5 times 5. Okay, great. So what do? So we put one of the 5s up here and the other 5 here. 5 times 5 is 25. So you put the 25 here and you take the difference. Okay? And you'll see 29 minus 25 is 4. Is that it? Do I just put remainder 4? No. If it was fractions, we would stop and say this is 5 4/5. But we're doing decimals now. Okay, so what we do is we pull out that hidden decimal point, which is right there. It's like a hidden superpower. Okay, and then we just keep adding zeros, as many as we need. I just add them one at a time as I'm going. Okay, and then I'm going to drop this 0 down because it doesn't change the number. All right, let's see. 5 times 7 is 35. 5 times 8 is 40. 5 times 9 is 45. Do you like any of these yet? Which one do you like? Okay, good. This one, right? Good. So this is 5 times 8. So this is the 5, and the 8 is here. 5 times 8 is 40. All right, is that it? 29 divided by 5 is 58. You can't get a bigger number out of something, out of this number, right? You can't be bigger than 29. What did we forget? We forgot to push up the decimal point. Okay, so my answer is 5.8. Somebody's asking, how do I check my answer to see if I've got the right one? Good question. So what this means is 5.8 times 5 if you multiply them together, we get 29.0. So if you multiply these guys together, you'll get what's in the box. If you divide what's in the box by one of these, you'll get the other. Isn't that a clever plan? I love the way math works like that. All right. Smile if this is starting to make some sense. How are we doing with this? Good? Oh, good. I see lots of smiles. I see a little worried face, but that's okay. The way you get good at math is by doing math. Here, let's try this one. I have 13 $1 bills, and I'm going to split it with you. You tell me, even? Does it work out well, or do we have... No, it doesn't. Of course not. And no, you may not take one of the dollar bills and rip it in half. That is so not a thing. Okay, so write me this thing. Who goes in the box? Who goes in the box? The 2? Are you sure? No. The 13 goes in the box. Good, the thing you want to divvy up and put into piles, okay? And there's you and me, so that's 2. So this turns into that. Good. 2 doesn't go into 1. How many times does 2 go into 13? Yeah, you can do this one. You don't need me to write that out, do you? How about 6? What is 6 times 2? 6 times 2 is 12. The difference between 13 and 12 is 1. All right. Pull out your decimal point, stick it on, put a 0 there, drop the 0. How many times does 2 go into 10? 2 goes into 10. You shout it out, you can show me your fingers. That's fine. Good. Yeah, 5. All right. So 5 times 2 is 10, and we have nothing left over. So 13 divided by 2 is 65. Is that right? We each got $65? No, you can't have $65 if you only have 13. So don't forget your decimal point, push it up. How much money do we each get? $6.50. Yep, exactly. Now, 6.50, if this was money, we would simply add another 0 on the end, so $6.50, okay? Or if this is, I don't know, muffins or something, right? You get 6.50. 0.5 is a half. All right. What about this one? What about this one? Let's talk about when it doesn't work out so nice. If I have 1 orange and I have 3 people, yeah, everybody's just getting a mouthful, right? How do I do this one? Who goes in the box? Actually, let me do this one on another piece of paper. I didn't give myself enough room. Okay. 1 divided by 3. 1 divided by 3. These are both 1 divided by 3. Good. Tell me, who goes in the box? The 1 or the 3? What are we dividing? And yeah, putting into piles. Yeah, the orange. Good. How many people want it? 3. They're standing outside waiting to get at that orange. Great. Does it look like this is going to work? It doesn't. Okay, so pull out your invisible decimal point and stick it in and start adding zeros. Does 3 go into 10? Absolutely. How many times without going over? 3 times. Yep, I'm seeing it now. Good. 3. 3 times 3 is 9. 10 minus 9 is 1. Okay, so we have a remainder. Let's put another 0. We're going to push that 0 down. How many times does 3 go into 10? Here, I'm going to push up the decimal point while we're here. Okay. 3 goes into 10, same thing, right? 3. 3 times 3 is 9. Okay, we have a 1. Let's keep going. Put this one down. Here's the other 0. Anybody seeing a problem? How many times are we going to be doing this? Can you say infinity? Do you see how it's going to go on and on? And this is how you keep kids busy who don't really understand math. You give them a problem like this and you say, tell me what the last digit. And they keep going and going and going. And after about 20 minutes, they're like, hey. All right. So what we do, because this one is going to go 3, 3, 3. See how it'll never work out? It'll always give you this repeating pattern. Sometimes repeating patterns are single numbers. Sometimes you'll have 0.12, 1, 2, 1, 2, or 0.123, 1, 2, 3, 1, 2, 3, or 0.21, 2, 1, 2, 1, 2, 1, 2, 1. So if you see a pattern like that, what we do is we put the dots and we go dot, 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 because it's more of the same. We say that 1/3 is 0.3 with a bar. And that bar means you repeat that. So if I had a bar, oh, so this is the answer for this one. 1/3 is 0.3 bar is how we'd say that. I don't know that I'd say 3/10 bar, I'd say 0.3 bar. About the bar, if that's new for you, if I said 0.713713, then this would become 0.713 bar, and the bar would go over everything that repeats. That's a 7. All right, smile if this bar stuff makes sense. You got that? So that's how we write that. Okay, great. Good, good, good. Okay. So let's try problems like you're probably going to have in your homework. So I have a number 148.5. All right, divided by 11. Maybe you made $148.50 at your lemonade stand and you had a bunch of people helping you. How much does everybody get? Everybody gets a fair share. Who goes in the box? What number goes in the box? You write it down and then write that thing out here and then show me. Okay, go ahead. I'm going to do mine off screen and then we'll compare. Let's see if I can get it all off screen. Okay. All right, when you're done, look up at me so I know. All right, lots of kids staring at me now. Okay, so here we go. Did you get this? Yeah? You got them in the right order? If you didn't, you're going to be doing a different problem. Okay, so 11s are fun, aren't they? All right, put your finger on the 1. That doesn't work. Put your finger on the 14. Does that work? Does 11 go into 14? Sure, absolutely. Okay, how many times? 1, right? So put your finger over it if you need to, okay? 1 times 11 is 11. So right now we're only looking at the 14. Sometimes these big numbers can get overwhelming, so just put your hand on it, okay? So 14 minus 11, that's easy, right? That's a 3, so write a 3 here. Okay, and then we're going to drop the next digit, which is the 8. Okay, now we're just looking at 11 and 38. How many times does 11 go into 38 without going over? Do you know your 11 times tables? Yeah, pretty easy, right? Okay, so how many times? Show me with your fingers. Beautiful, excellent. So I have a 3. 3 times 11 is 33. I'm seeing a number of you guys doing that, okay? Okay, so 38 minus 33, that's a 5. And then drop this 5. 11 goes into 55. Can you finish the problem for me? All right, don't look up here. Finish the problem for me. And then tell me what the answer is. So this thing is going to equal something. Tell me what it is. Okay. I'll finish it off screen, and then we'll compare. Okay, more off screen, I guess. There we go. Good, I'm seeing a lot of good answers. Uma, it looks like one of your numbers isn't right. All right, did you get this? Yay, excellent. Here, you back up a little bit. Good. All right, so how's this feeling for long division? How are we doing? You doing good? Okay, because I want to make sure we have enough time to do a couple more examples. We're going to do lots of examples today, so you're comfortable. Okay, good, good, good. And actually, I do have, yes, people are asking for a story already. You got to earn your story. 43.5 divided by 3. I want you to set it up. If you're already comfortable and you want to race me to the answer, you're doing that one. And you're also doing this one, 6.5 over 5. This is if it's easy. You're doing these two. All right, if this is new, we're going to focus on this top one first, okay? All right, so who goes in the box? It's always the numerator, okay? And then this guy goes here, and let's do it together. 3 goes into 4 how many times? Yep, 1 time. 1 times 3, I wish I had a third arm here, is 3. Okay, so we're just doing 4 minus 3. All right, so that's going to be a 1. Now we're going to drop that 3 down, so now we have 13. 3, how many times does 3 go into 13 without going over? see, 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5, oops, too much, right? So 3 times 4 is what we want up here, which is a 12. You'll know if you put the wrong number here and you'll divide and it'll be too big. So somebody was asking that. So good. Okay. All right, and sorry. And then we're going to drop the 5 down. 3 goes into 15 how many times? Can you finish this problem? Tell me what the final answer is. Yep, you can do it. What's the final answer? 3 goes into 15 that many times. And don't forget to push up the decimal point. Okay, so this equals 14.5. So if I take 14.5 and multiply it by 3, I'm going to get 43.5. Good. All right. Students that worked on this one, what'd you get for an answer for the lower one? I have some answers. Yes. That's right. You should get 1.3. Excellent. Good, good, good. Okay. Let's do one with a lot of zeros in it. Because sometimes zeros as a placeholder can be kind of confusing. All right, let's do this one. 0.558 divided by 6. Okay. All right, so what we do is we say 0.558, and then the 6 goes here. All right, so obviously that's 0. So we scooch over. Does 6 go into 5? Just ignore the decimal point. Now 6 doesn't go into 5, so we got to go over here. 6 goes into 55. All right, so let's see. 6 times 7 is 42. Here, help me. 6 times 8 is 48. 6 times 9 is 54. Oh, that's real close, isn't it? This one is. Okay, so I'm going to put a 9, and the 9 goes right over the second 5. You see that? All right, so it's important. If you put it here, you get the wrong answer by a factor of 10. Okay, so I'm going to put a 0. I'm going to push up the decimal point here. So that 0 is here. There was nothing in this case, so that's a 0. The 9 goes over the one I'm looking at. So I'm looking at 55, so the 9 goes there. Okay, 9 times 6 is 54. And so it's just a difference of 1. Drop the 8 down. 6 goes into 18. Remember your multiplication? 3 times, and it goes in perfectly. So the answer is 0.093. So we're taking about a half of something and dividing it among 6 people. And so everybody gets a little less than a tenth. Yeah, good. All right, how many people are feeling more comfortable now that we're doing lots of problems? More comfortable. Give me kind of a head nod. Yeah, feeling good. Okay, good. I notice a lot of you are taking notes. That is excellent. The best way to learn how to do this is to do it with me. So when I'm writing, you're writing, right? Just sitting back and kind of looking at me like this. Like, I already know this stuff. I'm not doing this for me. This is for you. So you're actively writing. You're thinking about things. Yep. And often when I was in school, if I started to feel like I don't understand something and I would stop taking notes, you ever feel that? I would make myself take notes anyway. And I'd say, it's okay that I don't understand it, just write it down. And sometimes the actual act of me writing it down, I would see something that my brain missed the first time when it was looking at the chalkboard or the whiteboard or whatever we're looking at. And the act of writing it down, be like, oh! And so I know that's sometimes common, especially when we're taking notes in a math class. You're like, but I don't get it. And you just feel like you need to stop. Yep, totally understand. Happens in calculus classes too. So just keep writing and then ask questions so I can answer them as we go. And actually a few of these I've picked because of the questions you guys are asking. Good. Okay. So let me do one more. What about this one? This is one you're going to see a lot of, especially if you want to be an engineer. 3/8 inch. All right. How do you set this one up? Come on, can you race me to it? Get the box. Who goes in the box and who goes outside? Go, go, go. Okay, Good. Okay, 3 goes into 8 how many times? Did I do this right? Or did I mess up? Yes, you got it. Yes, yes, yes. This is wrong. This is wrong. The numerator goes inside. I was trying to see if you were paying attention. Okay, so here we go. All right, we're dividing it into 8, and I've got 3. There we go. Yes, yes, yes. Here, put scribble marks there if you wrote that down. Okay, good. 8 goes into 3. It does not. So pull out your handy-dandy decimal point. 8 goes into 30. You betcha. It goes in how many times? Yeah, I'll put the decimal point. I'll push it up here. Put the 0 there. Okay. Goes in 3 times. 24. The difference is a 6. Good. Here's another 0. You can just add it. Okay. 8 goes into 60 how many times? Let's see. 8 times 7 is 56. 8 times 8 is, everybody knows that one, 64. That's too big. So let's do 8 times 7. And put the 56 here. I have a difference of 4. Good. And then, oh, I need another 0. Look at that. And that happens sometimes. Here's my 0. Does 8 go into 40 evenly? Head nod yes, or shake your head. Messy, messy, messy. Yeah, it goes in evenly, right? Because look, it's a 8 times something. Gives you 40. Here. Look at that. That's right. So put a 5 up there. And you have no remainder. Excellent. So 3/8 is 0.375 inches. All right. Good. Okay, so lots and lots of good practice. One more thing I want you to do. Stand up right now. Stand up, stand up. All right, stand up. Oh, shake your body out. Shake, shake, shake. Okay, we have one more thing, and this one's kind of sneaky. I don't know about you, but I don't know my 0.2 times tables or my 0.5 times tables. I don't know. I did not memorize those. So let me show you a trick. If the decimals get a little bit, you're like, hey, I don't even know how to deal with that. Let me show you how to do it. But first, let us have a snack. Do you have a quick little bite? All right, this is the last little thing I'm going to show you, and then we're done for today. I know, we did a lot of things today, didn't we? Okay, awesome. So let's go back down to my desk, and what if I have a decimal like this? All right, so the math can handle it. Numerator goes in here. Denominator goes here. Okay, uh-oh, right? How many times does 0.4 go into 6? I don't know my 0.4 times tables, so watch what we're going to do. I'm going to change this to a 4. And I can only do that if here's my decimal point, if I change it here too. You're like, wait, what? So what did I do to 0.4 to make it a 4? I multiplied it by 10. I can do that as long as I multiply the top by 10 too. So really the problem becomes 4 into, and when this goes over there, that's a 60. So I can multiply the top and bottom by the same number. In division problems, it just means both decimal points move, all right, to the same amount. And that's the only way you're allowed to do that. Okay, so can I do 4 into 60? Yeah, that's easy, right? 4 goes into 6 one time, minus 4. Here's a 2, drop the 0. And 4 goes into 20 5 times, and it goes in evenly, and there's actually no decimal. So the answer to 6 over 0.4 is 15. And you're like, whoa, this number is bigger. How come we got a bigger number than this? This was a pile of 6 marbles. It's because we're dividing by a number that's smaller than 1. It will give you a larger number. Okay, so while you're writing this down, for those of you who really want to see what's going on, let's open the hood of the car just for a second. This is a 6 divided by 4 over 10. And if you remember from fractions, this is a 6 on the top times, and then we take the reciprocal, 10 over 4. Do you see how this is 60 divided by 4? And do you see how that matches this problem right here? Oh, yes. It's because this bottom one's a decimal. So if you have a decimal in the denominator, expect your number to be bigger than you had originally in the numerator. All right, put the hood back down. All right, so let's try another one. Okay, let's try another one. How about if I have 4.8 and I want to divide it by 0.6? A lot of decimal points. Okay, so put it in the box first. The numerator always goes, whoops. How about I write the right number? 4.8 divided by 0.6. Sorry. I have 4.8 in the box, 0.6 outside. Okay. So I need to make this a whole number. So I'm going to do one bunny hop here, and I better do it there too. And again, all that means is I'm multiplying the top and bottom by 10 because I want to make this a whole number. I don't want it to be a decimal because that makes my division very difficult. So this is going to be a 6 into 48. And you can do that in your head, can't you? Yeah, what's the answer to this guy? 4.8 divided by 0.6 equals 6 goes into 48 8 times perfectly. Like, that's the answer right there. Good. All right, how are you feeling about this now? Pretty good? Yeah, this bunny hop thing, can you see how this would be helpful? All right, one last thing I want to ask you. I don't want you to do the division. I just want you to modify it. Can you do it for me? Okay. So modify this one. I'm gonna write a couple of them down. Okay, because you're already experts at division now. I just want you to modify them so they're easier for you to do. Don't actually do the division. Just do the bunny hop thing. Okay. All right, for this one, you've got 1, 2 bunny hops, don't you? 1, 2. Okay, and anytime you see a blank spot, that's a 0. So if I rewrite this, this is going to be 3 into 480. And that's the division problem you do. Can you do it for this one for me? Don't do the division, just set it up. How many bunny hops do we need to do? You need to make this a whole number. So for this guy, it's only 1 bunny hop. Good. So there's only 1 bunny hop here too. Okay, so this is not 7 into 35. It's 7 into, what's the number here? 3.5. Yeah, do you guys see that? Okay, good. Oh, good. I'm seeing a lot of head nods. Good. Okay, so 1 bunny hop here. So what's this one look like? 6 into, what's the number inside? 11.4. Good. Okay, bonus extra credit. What's this one? I'll give you a second. Yep, that's right. 2. So that's going to be a 4. But what's the number inside? What do you think about that? It's not 12. Nope. There's 2 bunny hops here. So you better do 2 here. And if there's an empty, we put the 0. Awesome. You guys see how to modify the problem? So I'm multiplying by 10 here. That's how I did 1 bunny hop. I multiplied by 100 here, both numbers. You see how they're different? Good, good. Okay, here we go. Quick quiz. How would you modify this one? Modify that one and then this one. Don't do the division, just modify them. Okay? How would you make them so they're easier? You want me to do one more. All right, let me see. Let me see if I have time. Okay. Did you get that one? Okay, so 1 bunny hop here turns this into a 15 into 4.5. Good. What about this one? What did you get for this one? Yeah, 1, 2. 1, 2. So that becomes an 11 into 6, 6, 0. Beautiful. All right. Yay. We did it. We did it. Awesome. You guys did so good. So good. So how are you feeling about this now? Are you feeling like, hey, that's not that hard? Yeah, it takes time, right? But you can do it. And once you see it and do the pattern, It totally works, doesn't it? It totally works. Awesome. Okay, so you're all done. Put your pencils down, shake it out, grab a bite. Once upon a time, there was a math teacher who was actually an engineering student, and I decided that I wanted to bake a cake. Now, back in those days, I was not very good at baking. And so, you ever gotten distracted? Yeah, we all have, right? Distracted by something. Okay, so this is before there were cell phones, before there were laptops, right? Okay, so I decided I'm going to make a cake, but I'd never made a cake before, and I said, okay. And so my friend had called me. We were both, I think we were undergrad students at that time. We were like seniors at college. And so I've got half of the ingredients ready. And, have you ever made a cake from a cake mix, like the box? It says, you need eggs, oil, and what's the other thing? Eggs, oil, and water, I think. Okay, those three. Okay, so I've got those things out. And right when I'm reading the box, the phone rings. So I get up here, and I get the phone. And the phone is, of course, attached to the wall. And so I just, so I'm talking, and I'm stirring things up, and we're talking about class and how cool it was and all these fun things. And she's telling me about she has a new Mustang. She goes, you got to go for a ride. My new Mustang. It's a graduation gift from my parents. She goes, and she goes, I have a remote control for my car. I'm like, and then, okay, remember, I had a truck back then, and, it didn't even have carpet. It didn't even have, it had some seatbelts. And so my pickup truck stories are, I know, fun. So I'm like, you have a remote control for your car? Like, how does that even work? And she goes, oh, come on over. So I was so excited about this, I completely forgot what I was doing. I had put the cake in the oven by this point. And so she goes, I'll come by. So we go outside, and she's got her Mustang, and it was like one of those tricked out, beautiful Mustangs. It must have been 1996, back when Mustangs were like real muscle cars, right? Now they don't quite look the same. So she's got this Mustang. She goes, watch this. And she pushes a button, and all the windows go up, and the whole thing starts to vibrate and goes, bum, 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 bum. I'm like, what is going on? And she says, the speakers are too loud. It'll damage human hearing. So what they do is they give you a remote, and you push this button. It cranks everything up. It turns the stereo to its maximum volume, and then you can use your car like a boombox, you don't know what boomboxes are, like a stereo, like a portable stereo, right? And I'm sitting there, and I'm like, that's the most ridiculous thing I've ever heard. Like, who uses their car as a portable stereo, right? That's great. My truck didn't even have music. It had a radio. That was it, right? And she's got CD players. And anyway, needless to say, I was a little bit wishing I had one of those. Anyway, so it was super fun. I get back in. I'm like, oh, you know what? My cake's almost done. And so she goes, I'll come in and take a look. And she goes, what flavor? And I said, of course, chocolate. So I go in. I kid you not, I didn't even notice the box was still on the counter. I opened the thing, I go to pull it out. Do you think a beautiful cake was there? Guess what I forgot to put in? The cake mix is still sitting in the box. I pulled out in my pan. Apparently my brain just checked out. I had put oil, eggs, and water and beat them up and made this gooey mass. And she's so polite. She goes, well, that's the most interesting cake I've ever seen. She goes, do you want me to take you out for a pizza or something? I'm like, yes, please. And I look at the cake mix. I'm like, oh my goodness, I forgot it. I left it on the counter. I was so talking to you. Yes. So Aurora got distracted. Yay! And then, and I can tell you about the pasta that that I made glue one time, and I served it for dinner. So forgot a secret ingredient in my pasta. But the two guys actually ate it anyway. They were sitting there and like, it's so chewy. And I'm like, oh no, I forgot something. And they were basically eating glue for dinner. All right, so yay! Note to self, that's how you improve. So if you ever feel like, I just don't get the hang of this, I keep making mistakes, we all do. And guess what? I'm actually a pretty good cook now. But it's only because I made mistakes. Anybody snow ski? Anybody, and do I have any snow skiing kids out there? Okay, you tell me, or snowboarding or anything, right? You tell me, are the best skiers the ones that fall down or the ones that are afraid to fall and they go really, really slow? No, they're the ones that are making snowballs, right? Because the more you fall, the better you are. So there's this thing that a robotics team is known for saying. It's called fail faster. It means make your mistake, get up, brush yourself off, move on. Try something else. Make another mistake, get up, brush it. Don't stay sitting in the snow and being upset that you fell in the first place. Just get up, shake yourself off. It happens. Just go do it again. Same thing for math. So if you're doing math problems and you're like, I just made another mistake, that's okay. Crumple it up. Paper is cheap. Grab another sheet of paper. Try it again. So fail faster. I want you to make all the mistakes you can because that's how you get better. It's when you watch videos, sometimes when you watch me even and you see me do these problems, you're like, wow, she's so great. She gets a perfect right answer every time. It's only because I made 9,000 mistakes. So I'm expecting you to make some mistakes. Nobody expects you to get it perfect the first time. So fail faster, make as many mistakes as you can, learn from them. Don't go at top speed where you just skip over your mistakes and you keep making the same silly mistakes over and over. Learn from them and say, oh, you know what? I'm always dropping my decimal point. I'm going to make it big and fat, no problem. Or whatever it is, right? So keep in mind where your pitfalls are and then do what you can to correct them so you can go faster. Remember, we start slow in the beginning and slow is smooth. Smooth is fast. Smile if that makes sense. Yeah, so we go nice and slow in the beginning. We want you nice, smooth, get all the wiggles and all the kajinks and all the hiccups and bumps out, and then you can go faster. Yes. All right, that's what I have for you today. I hope it was really fun. You know what you're going to do now? That's right. You've got some fun things coming your way. How many of you like the binary puzzles? Did you guys try those from last week? You need to. If you haven't, you totally need to. Okay, let me show you what your assignments are for this week. Go to Decimals, session number 5. Today's recording will be right under the parent video as soon as we're done with class. Session number 5, parent video is here. The handout that I had mentioned in class that we were working from is here. You can see this is the handout and the graph paper that I had mentioned at the beginning. That was the second button here. Oh, I don't have a cursor. You'd think I'd know this by now. Let me grab my cursor. There we go. Nod your head. Do I have a cursor now? You guys can see my cursor? Yeah, okay. All right, great. Math assignment outline. What do you have in store for this week? You have a whole bunch of fun stuff. If you like scavenger hunts, well, first things first, you have your workbook. You're going to work on decimals, workbook number 3. You're going to do most of it. So you already did the first few pages. I want you to complete most of the workbook, do the test at the back. Remember, you don't have to do every single page. Those of you who like me doing the workbook with you, scroll down until you see decimals workbook number 3, and here are step-by-step videos of me working through the workbook with you. And even on the workbook, I'll say, you do half, I'll do them all, and then we'll compare answers. Let's have a race, ready, set, go. And then you usually are supposed to hit pause on the video. and then we'll compare answers. Okay, so remember, the workbook is a tool to get good at what we're talking about here. And once you get it and you're like, oh, I'm getting the right answer every time, skip it, move to the next part. You do not have to do the entire workbook. Let's see, where are we? Workbook. Okay, scavenger hunt. Those of you who enjoy scavenger hunts, you can see I put one together. My kids actually did this one. They had a blast. And they had to retrace their steps because they screwed up a few times. So this is a fun scavenger hunt for you to do. Then we have order of operations, we have mazes, we have a game. Do you guys like board games? So there's a game called Decimal Dash. You'll be able to do that. And then the Powers of 10 packet. There's a reverse scavenger hunt, which is the opposite of what we just did. This is one scavenger hunt forwards. This is the one that's backwards. You can do both. And then let's see, what else do we have? Decimal of the day. Okay, please, eyeballs up here. If your parents are in the habit of just printing everything and handing it to you, do not print out this whole thing. It's like 100 pages. So open it, and then you pick the decimal you like. And then it's just one page for that decimal. So there's a whole bunch of them, and then you just select the decimal that you want to do. If you just need a little bit of practice, just pick one decimal. That's why it's called decimal of the day. You're supposed to do one a day for like a month or something. My guess is you'll get the hang of it after about like 4 or 5 of them. Okay, how many of you like chemistry? Any of my chemistry chemists out there? Okay, so we actually have a chemistry lab for you this week. I put this together. This is taken from a high school chemistry course. So there are step-by-step instructional videos that go with this. If you just print this out, you will be lost because you don't have the background. What we're going to be doing with this one here, I'll just jump down to it. Chemistry, what we're going to do is, let's see, chemistry lab. Okay, I'm going to show you how chemists use math, specifically decimals, in their labs. So I will write down the equations. You are going to do the division. Okay, so I'm going to show you where the practical application pieces are, and then in lots of different labs. So this is, you are already in a chemistry lab with me. I'm going to do the hard part with all the chemistry, and I explain what's going on. You know, we're burning some sulfur in here. We're setting it on fire. What does that chemical reaction look like? And then how does decimals come into it? Where does that look like? Okay, so you're just going to follow along with me. Significant figures is in here. This is where, remember where I said you can add zeros all day long and it doesn't matter, it doesn't change the number? A number of you said, I want to know when it does change the number, just by adding zeros. And so that video is in here. So that's video number 3. And then precision and accuracy, that one's in here. And then if you want to learn those, who doesn't like a good fire, right? If you're interested in combustion, that was what my research was in as a graduate student, was in combustion. So I have a propane problem here for you. And so again, this is a high school and college level class. Actually, this one's from college. This is me describing the combustion process, me writing down the chemical reaction. Again, you're not expected to know how to do that, but I do want you to see how we use division and how we use decimals. This is exactly where your math skills are going to come in. So this is really, really fun. So these labs are important, so you see what is this math stuff used for. So yeah, being able to relate that to the real world. Okay, and all of you who like to take a bath, here's your chemistry challenge. Or not chemistry, I'm sorry. Here's your math challenge. And so all you have to do is read that and tell me, what do you think? Do you think it'll happen? Do you think it won't? In fact, a number of kids that worked on this last time actually got into the bathtub because they weren't sure of the answer. And so they had to figure it out. All right, so go ahead and give that a go. I hope you've enjoyed our classes. Yay! You have more than enough to get started. I'm going to close this out because we have an algebra class in 6 minutes that I need to get ready for. So if you had fun, give me a great big smile, and I will see you next time. Bye-bye, everybody.